Hello everyone. This video is about how to connect such a wireless PTT or push to talk button to an Arduino Nano IoT. Such PTT buttons are usually used for the Cello PTT app, which is kind of a walkie-talkie app for cell phones. This button connects through BLE or Bluetooth Low Energy. And this is one of the features of the Arduino Nano IoT or Internet of Things. So when you press this button, it will be picked up by the Arduino, and then you can use it as a convenient remote control of some sort for your own projects. These buttons come in many different flavors. This particular one is Next AV or NextDev PTT U2L0. You can pick up such a device on Amazon for about $30. The Arduino Nano IoT is a relatively new product. You can pick it up for about $20. And the good thing is that it features a lot of connectivity, among other things, as mentioned, Bluetooth and Bluetooth Low Energy, just as a number of Wi-Fi features. Before we can proceed connecting our button to the Arduino, we need to understand a little bit more about the technology behind BLE. One thing to keep in mind is that BLE devices come in two flavors, clients and servers. And it may be a little counterintuitive, but our button counts as a server in the sense that it offers a service that can be consumed by another device like our Arduino, which in that sense would be a client. There's a lot of information out there on the internet on Bluetooth Low Energy, and a relatively good overview, for example, is given on the homepage of Microsoft here under docs.microsoft.com. Another thing to keep in mind is that two main elements of a BLE attribute are services and characteristics. In this example, the service is a heart rate service, so reading the values of a user's heart rate monitor, and individual characteristics are certain variables or measurements that are sent by the device. For example, here one characteristic is the heart rate measurement, the next one is the body sensor location, and the third one is the heart rate control point. With our simple button, we will see that we will have only one characteristic, which is a key pressed characteristic, which has the value of 0 if the button is not pressed and 1 if the button is pressed. Our next step is now to find out more about the technology and features behind the PTT push button, and for that purpose we will use the Bluetooth BLE Explorer software as it is offered for free on the homepage of Microsoft. This software allows to detect BLE devices in the neighborhood that are offering their services and to find out more about the services and characteristics and also the associated Bluetooth addresses. Okay, so now I have started up the Bluetooth BLE Explorer software, and if I click on Start Now, it should discover all the BLE devices in my neighborhood. And as it happens, if we look through the names of the discovered devices, it seems to me that this PTT-C is most likely our device, the Bluetooth PTT button. So we can do a double click on this device, and we will see the attribute, so to say, with the offered services and the associated characteristics. In this case, it seems we have here a little bit of generic stuff like the name and so on. And I can tell you right now that this will not be really important for us. We also have two services here, a generic attribute, which isn't important for us either. But here we have the interesting service, which is here offered under the name 65504. We should remember that because we will need it later on in the source code. And this service represents a simple key state, and unfortunately the associated value cannot be read. So that's another peculiarity about BLE, because there are two ways how you can get the value of a characteristic. One is just read it through a read method, and the second one is subscribe to the value, and then you get notified when the value changes. As it turns out, in this PTT button, you cannot read the value, you can just subscribe to it, and then as a consumer of this service, you will get notified if the value changes. I can demonstrate that also here in Windows. Like if we do a double click on this characteristic, we will see again that reading the value is not permitted. But what we can do is we can use Windows notifications to subscribe to the value. So if I now press the button, we get a message that the characteristic value of the simple key state service is 1, and now I release the button, I get another message or notification that the value is now 0. So we can repeat that a few times. Press it, release it, press it, release it. Okay, so that's pretty much everything we need. We keep this service name in mind, 65504. And what we also need to keep in mind is the Bluetooth address of the button. And with these two values, we will be able to read the button's value, or better, to receive a notification if the value changes on our Arduino. Okay, now we are ready to look at the source code, which I have also uploaded to GitHub under rx-tx-87, and the folder name is Arduino_IoT_BLE_PTT_Button. This sketch that I will show you now is loosely based on one of the Arduino BLE examples for central and LED control. However, it took me a little while to make the example work due to the fact that you need to subscribe to the PTT push button and cannot read the value directly. So this code works with a timer interrupt, and there are two flags, so to say. One flag is every 5 milliseconds in the main loop, and then certain things will be done, and the other flag is set every second. And the main thing I wanted to point out is how the connection is managed. So this button, it has this variable BLE PTT button status, which can have one of three values. if the value is 0, it will scan for a BLE device. If the value is 1, it has already found or successfully found the PTT button and now will try to subscribe. And if subscribing succeeds, it will go to status 2, which is successfully subscribed, or the operational state. These status steps are part of the 1 second timer. So that means, for example, if the scan is initiated, it will wait a second to find the Bluetooth device, and then it will try to subscribe. And if that succeeds, it will go to the operational state. So in the setup method, we have this BLE begin, and then the next specific BLE method is this BLE PTT button start scan. And here we scan for the address, the Bluetooth address. I also tried to scan for the associated user or unique user ID, but unfortunately that wasn't successful. So if this scan is initiated, you can see that the status variable is increased by 1, so goes from 0 to 1. And this means that during the next 1 second timer interrupt, the code will try to subscribe to the value, to the button value. And for that, it will go through a series of steps. First of all, it will print a bit of debug message, a few debug messages in the serial or through the serial port. If anything goes wrong, it will also write an error message to the serial port. But if successfully a device could be found, it will stop scanning and go to the next level, which is trying to connect to the peripheral device through the connect command. And if it fails to connect, it will go back to status 1. So this here is status 1. That means it will just try to connect again. At the next level, an attempt will be made to discover the attributes that are offered by the device through the discover attributes. And then it will try to discover the service with this service number 65504 that we have seen, which is the simple key service. And as a next step, normally you could try to read the characteristic from this service, but in this case you cannot read it because it's kind of blocked. You just can't subscribe to it. So therefore in this area it will be checked whether subscription is possible, and yes it is. And in case we can subscribe, we issue the subscribe command, and then the status will go to 2, which means we are successfully subscribed and are now kind of operational. Before we proceed to the main loop where the button reads are evaluated, I briefly wanted to show you the timer routine, which is by Nebs Petrovic, based on some work by Max Bader. And here, if you're interested, as a side note, you can look at how to set up a timer on the Arduino Nano IOT. Here you can see that the timer is set to 5 milliseconds, so there will be an overflow interrupt every 5 milliseconds. And if we go back to the main loop, you will see that every 5 milliseconds it will be evaluated whether the button was pressed. For that matter, it is checked whether we are still connected. And if yes, it is checked if the value was updated. And this is, so to say, how you can read the value that we have subscribed to. So the read method will not work. It will only work after the value was updated. Then you have permission to read the value. That is the concept of this subscription and notification system that we have here. Here you can see the code to switch on the red LED that we saw earlier on if the button was pressed. And in case the connection was lost, we'll just go back to status 0, and then the 1 second interrupt will, or the 1 second timer, I should say, will try to connect again. Now we can also check the whole thing through looking at the debug monitor, through looking at the serial monitor. Sorry, I need to connect the Arduino. So hopefully this works now. And here you can see the button is switched off at the moment, and it will try to connect every second. Now switch on the button, and it immediately found it and connected to it, and also subscribed to the simple key value. And if I now press the button, it's 1. If I release it, it's 0, and so on. Can press a few times. Now if I switch off the PTT button, after a little while it will recognize that it got disconnected, and that then it will try to reconnect again until I switch it on again. Now I switch it on, and then it discovers the button again, and it is operational again. Okay, that's it for today. I hope you enjoyed this video. Thanks for watching, and stay safe.